In the 18th century, the city of Königsberg stood proudly on the banks of the Pregel River, its landscape beautifully dissected by 7 majestic bridges. These bridges connected 4 landmasses, 2 large islands and 2 mainland portions. The citizens of Königsberg delighted in strolling across these bridges, weaving in and out of the islands, pondering an innocent but perplexing question. Could one walk through the city, crossing each of the 7 bridges exactly once? Many had tried, many had failed, and the bridges of Königsberg became the city's most enduring riddle, a challenge that no one had yet been able to conquer. Whispers spread through the city about the impossibility of the task. Some claimed it was a trick of the gods, a divine puzzle meant to humble humanity. Others believed it was a test of brilliance, waiting for the one mind sharp enough to unravel its mystery. Leonhard Euler, a mathematician of extraordinary genius, was known throughout Europe for his ability to solve problems that others deemed impossible. His reputation had reached Königsberg, and the people were hopeful. If anyone could conquer the bridges, it was Euler. When Euler arrived, he did not rush to walk the bridges or trace paths with chalk. Instead, he retreated into the quiet of his study, leaving the townsfolk to wonder if he, too, would be defeated by the bridges. But Euler was no ordinary thinker. He understood that the problem was not just a matter of finding the right path, but of understanding the very nature of the paths themselves. In the solitude of his study, Euler began to see the city not as a physical place, but as an abstract network. He realized that the problem of the bridges was not about geography, but about connections. The land masses are vertices, linked by the bridges or edges. With this insight, Euler stripped away the unnecessary details, reducing the entire city of Königsberg to a simple diagram. The land masses became points on a page, and the bridges lines connecting them. It was no longer a question of walking through the city, but of tracing a path through a network. As Euler analyzed the network, he made a critical observation. Whenever someone enters a landmass or vertex by crossing a bridge, they must also leave that landmass by another bridge, except at the starting or ending point of the walk. This means that for any path that uses each bridge exactly once, the number of times a person enters a landmass must equal the number of times they leave it. For this to be possible, the number of bridges connected to each landmass, except the starting and ending points, must be even. This is because half of the bridges will be used to enter the landmass, and the other half to leave it. However, in the original Königsberg problem, every landmass is connected to an odd number of bridges. Specifically, one landmass is connected by 5 bridges, and the other 3 are each connected by 3 bridges. Since only 2 landmasses can serve as the start and end points of the walk, this means that at least 2 of the landmasses with an odd number of bridges would need to be passed through in the middle of the walk. This meant that the task was mathematically impossible. No matter how one tried to cross the bridges, they would always find themselves stuck, forced to recross a bridge or end at a dead end. With a stroke of his quill, Euler wrote down his conclusion. It cannot be done. The bridges of Königsberg, which had puzzled the city for so long, were finally understood, not through trial and error, but through the power of mathematical reasoning. The city of Königsberg buzzed with the news. Euler had done the impossible, not by finding the path, but by proving that no such path existed. Euler's solution did more than answer a local curiosity. It laid the groundwork for a new branch of mathematics, graph theory. From the bridges of Königsberg, the world of mathematics would expand into networks, connections, and the deep interplay between structure and possibility. The bridges of Königsberg became legendary, not for their physical crossings, but for the journey they inspired, a journey into the abstract, into the heart of mathematics, where the impossible could be understood and in understanding, conquered. And so the legend of the Königsberg Bridge problem was born, a tale of curiosity, intellect, and the triumphant power of the human mind.